Hello, we are discussing about GATE 2003 ECE paper, and this question is related to analog circuits. An ideal sawtooth voltage waveform of frequency 500 Hz and amplitude 3 volts is generated by charging a capacitor of 2 microfarad in every cycle. The charging requires A. Constant voltage source of 3 volts for 1 millisecond. B. Constant voltage source of 3 volts for 2 milliseconds. C. Constant current source of 1 milliampere for 1 millisecond. D. Constant current source of 3 milliamperes for 2 milliseconds. So what will be the right answer for this question? So we are generating an ideal sawtooth voltage waveform of frequency 500 Hz. So frequency 500 Hz, f is equal to 500 Hz, which implies nothing but we can get the one time period. One complete cycle is nothing but 1 by f, which is nothing but 2 milliseconds. So one complete cycle is 2 milliseconds. The output waveform we can draw like this. This is what t, okay, and the output waveform can be written in this way. So sawtooth waveform, it is generated. Ideal sawtooth waveform will have 0 retrace time, so that it is going to be instantaneously returned to 0. Okay, so this is 0 and it is 2 milliseconds. This is 4 milliseconds. Time will be in milliseconds, and the maximum voltage it is reaching is nothing but 3 volts. It is what the output waveform, ideal sawtooth voltage waveform, is generating across a capacitor, okay, and whose capacitance value is 2 microfarad. And we know the relation between voltage and current of a capacitor. So Vc of t, voltage across the capacitor, is equal to 1 by C times of current flowing through the capacitor into dt. So from this equation, if you observe, let us assume current flowing through this capacitor is constant. By that time, this can be written as, assume that one I is going to be the current flowing through the capacitor. Okay, so by that time that constant can be written outside, so it will become I by C, integral of dt, that will become t. So Vc of t can be written as I by C into t, that is nothing but I by C is nothing but slope into t, so which is nothing but linearly varying, that is it is going to be looks like straight line equation with positive slope. So V naught of t, the output voltage generated, is also a straight line with positive slope. So Vc of t should be equal to 3 volts at the end of 2 milliseconds, because time period is 2 milliseconds. At the end of 2 milliseconds it has to reach 3 volts. So we can write like this: at t is equal to 2 milliseconds, Vc of t should be equal to 3 volts. By that time, how much is going to be the constant current supplied? Okay, so constant current should be supplied for 2 milliseconds, because at the end of 2 milliseconds the capacitor voltage has to be equal to 3 volts. So for 2 milliseconds you must provide constant current. What is the value of constant current? Now we will calculate from this equation. Vc of t is 3 volts, so substitute it as 3 is equal to I by C. I is nothing but constant current divided by C is nothing but 2 microfarads. 2 microfarads into t is nothing but 2 milliseconds. Okay, so 2 get cancels. What you will get is nothing but 3. So I is equal to 2 milliamperes you will get. This is volts, and what you are getting is I is equal to, I is equal to 3 milliamperes you will get. That 3 you will get. So I is equal to 3 milliamperes. So a constant current of 3 milliamperes should be supplied for 2 milliseconds. By that time, at the end of 2 milliseconds, the capacitor is going to be generating, the voltage across capacitor is going to be equal to 3 volts. So the charging requires constant current of 3 milliamperes for 2 milliseconds. So the right answer for this question is D. Thank you.